Pointer data type and pointer variables. Chapter 2, define a data type as a set of values together with a set of operations. Please hit the like button, leave a comment, and subscribe to the channel. If you are unable to do that, you will need to log in. If you do not have a YouTube account, you can create one free, and it takes less than a minute. Recall that the set of values is called the domain of the data type. In addition to these two properties, until now, all of the data types you have encountered have one more thing associated with them, the name of the data type. For example, there is a data type called int. The set of values belonging to this data type includes integers that range between -2,147,483,648 and 2,147,483,647, and the operations allowed on these values are the arithmetic operators described in Chapter 2. To manipulate numeric integer data in the range -2,147,483,648 to 2,147,483,647, you can declare variables using the word int. The name of the data type allows you to declare a variable of that type. Next, we describe the pointer data type. The values belonging to pointer data types are the memory addresses of your computer. As in many other languages, there is no name associated with the pointer data type in C++. Because the domain, that is the set of values of a pointer data type, is the addresses or locations in memory, a pointer variable is a variable whose content is an address, that is a memory location, and the pointer variable is said to point to that memory location. Pointer variable, a variable whose content is an address, that is a memory address, and is therefore said to point to a memory address. As remarked previously, there is no name associated with pointer data types. Moreover, pointer variables store memory addresses. So the obvious question is, if no name is associated with a pointer data type, how do you declare pointer variables? When you declare a pointer variable, you specify the data type of the value to be stored in the memory location. The value of a pointer variable is an address or memory space that typically contains some data. Therefore, when you declare a pointer variable, you also specify the data type of the value to be stored in the memory location pointed to by the pointer variable. For example, if a pointer variable contains the address of a memory location containing an int value, it is said to be an int pointer or a pointer variable of type int. As with regular variables, pointers are bound to a data type, and they can only contain the addresses of or point to variables of the specific data type they were created to hold. C++ allows the user to pass an object of a derived class to a formal parameter of the base class type. Address of operator AND. In C++, the ampersand and, called the address of operator, is a unary operator that returns the address of its operand. For example, given the statements int x, int asterisk p, the statement p equals sign and x assigns the address of x to p. That is, x and the value of p refer to the same memory location. Let's compare names and pointers. In the following two declarations, num1 and num2 are int variables and numtr is the name of an int pointer, int num1, num2, int asterisk numter. To prevent the access of private member variables out of the class is not a use of the address of operator AND. Dereferencing operator, asterisk. Every chapter until now has used the asterisk character asterisk as the binary multiplication operator. C++ also uses asterisk as a unary operator. When used as a unary operator, asterisk, commonly referred to as the dereferencing operator or indirection operator, refers to the object to which its operand, that is the pointer, points. For example, given the statements int x equals sign 25, int asterisk p equals sign and x / store, the address of x in p, the statement cout asterisk p, endl, prints the value stored in the memory space pointed to by p, which is the value of x. The dereferencing operator in C++ refers to the object to which its operand points. Classes, structs, and pointer variables. In the previous section you learned how to declare and manipulate pointers of simple data types, such as int and char. To simplify the accessing of a class or struct with a pointer, C++ provides the member access operator arrow. You can also declare pointers to other data types, such as classes. You will now learn how to declare and manipulate pointers to classes and structs. Recall that both classes and structs have the same capabilities. The only difference between classes and structs is that, by default, all members of a class are private, and by default, all members of a struct are public. Therefore, the following discussion applies to both. Initializing pointer variables. Because C++ does not automatically initialize variables, pointer variables must be initialized if you do not want them to point to anything. Pointer variables are initialized using the constant value 0, called the null pointer. Thus the statement p equals 0 stores the null pointer in p, that is p points to nothing. Some programmers use the named constant null to initialize pointer variables. The named constant null is defined in the header file cstdf. C++11 standard provides the null pointer nullpeter to initialize pointer variables. A pointer with the value nullpeter points to nothing and is called the null pointer. Nullpeter has a special value type that can be converted to any pointer type, inheritance as public, protected, or private. Suppose class B is derived from class A, then B cannot directly access the private members of A. That is, the private members of A are hidden in B. What about the public and protected members of A? This section gives the rules that generally apply when accessing the members of a base class. Given a pointer p of type double, the statement p++ increments the value of p by 8 bytes. Dynamic variables. The operations that are allowed on pointer variables are the assignment and relational operations and some limited arithmetic operations. The value of one pointer variable can be assigned to another pointer variable of the same type. When a program no longer needs a dynamic variable, the operator delete is used. When a program requires a dynamic variable, the operator new is used. Unused memory space that cannot be allocated is referred to as a memory leak. Dynamic arrays. In Chapter 8 you learned how to declare and process arrays. The arrays discussed in Chapter 8 are called static arrays because their size was fixed at compile time. In C++, a pointer can be passed as a value or reference parameter. One of the limitations of a static array is that every time you execute the program, the size of the array is fixed, so it might not be possible to use the same array to process different datasets of the same type. One way to handle this limitation is to declare an array that is large enough to process a variety of datasets. However, if the array is very big and the dataset is small, such a declaration would result in memory waste. On the other hand, it would be helpful if, during program execution, you could prompt the user to enter the size of the array and then create an array of the appropriate size. This approach is especially helpful if you cannot even guess the array size. In this section, you will learn how to create arrays during program execution and process such arrays. The statement int star array name bracket, 4 bracket semicolon creates a two-dimensional dynamic array of 4 pointers in which each pointer is of type int. An array created during the execution of a program is called a dynamic array. To create a dynamic array, we use the second form of the new operator. A pointer variable can be passed as a parameter to a function either by value or by reference. To declare a pointer as a value parameter in a function heading, you use the same mechanism as you use to declare a variable. To make a formal parameter be a reference parameter, you use ampersand when you declare the formal parameter in the function heading. Rearranging in a user-specified order is not a common operation performed by a list. Shallow versus deep copy and pointers. In an earlier section, we discussed pointer arithmetic and explained that if we are not careful, one pointer might access the data of another, completely unrelated pointer. This event might result in unsuspected or erroneous results. Here we discuss another peculiarity of pointers. To facilitate the discussion, we will use diagrams to show pointers and their related memory. In a shallow copy, 2 or more pointers of the same type point to the same memory location. A class containing 1 or more pure virtual functions is called an abstract class. Classes and pointers, some peculiarities. In a previous section, we discussed how to use the arrow notation to access class members via the pointer if a pointer variable is of a class type. Because a class can have pointer member variables, this section discusses some peculiarities of such classes. The object object1 has a pointer member variable p. Suppose that during program execution the pointer p creates a dynamic array. The copy constructor does not automatically execute when, as a parameter, an object is passed by reference. When object1 goes out of scope, all of the member variables of object1 are destroyed. However, P created a dynamic array, and dynamic memory must be deallocated using the operator delete. Thus, if the pointer P does not use the delete operator to deallocate the dynamic array, the memory space of the dynamic array will stay marked as allocated, even though it cannot be accessed. The items in an ordered list are in ascending order. An ordered list is a collection of distinct elements of the same type. To see more videos like this, please click in the rectangle in the middle of your screen. To see other videos from this channel, please click the circle on the bottom right.